So we're right back at it. Example 3. For each of the following functions, identify the vertical asymptote, horizontal asymptote, point of discontinuity, x-intercept, y-intercept. As well, we want to state what the domain and the range will be. So our first step in doing this is we're just going to factor this. I pull the x out of this and I get x plus 5. And then on my bottom, I'm looking for two numbers that add up to 7 and multiply out to 10. So we get x plus 2, x plus 5 right there. Now, from before, we notice that we're going to get that cancellation on my x plus 5. So that means that I'm going to now have y equals x all over x plus 2. With that x all over x plus 2, let's use this to identify our features of this graph. The vertical asymptote would be the one that didn't cancel, so it would be x equals negative 2. The horizontal asymptote, I notice the power on the top and the bottom match, or the degree on the top and the bottom match, so I divide the lead coefficients and it equals 1. One thing that you guys will notice, it doesn't matter if I look for the horizontal asymptote at this step or at this step, because it's going to end up being the same thing. My point of discontinuity, the x value of it is going to be negative 5, and then the y value of it, so I go y equals negative 5 all over negative 5 plus 2, which equals negative 5 all over negative 3, which would equal 5 over 3. So it would be at negative 5 comma 5 over 3. My x-intercept occurs when the top equals to 0 after I do the cancellation, so my x-intercept is just going to be when x equals 0. My y-intercept occurs when I substitute 0 in for x, and we can see, since we have the x on the top, that my y-intercept is going to occur at y equals 0. Now, for my domain and for my range. We have a couple of points that are removed from x, and we have a couple of points that are removed from y. I'm just going to put y equals 1 right there. X cannot be equal to negative 2, nor can it be equal to negative 5. Y cannot be equal to 1, nor can it be equal to 5 over 3. So my domain is just going to be x, where x does not equal negative 5 comma negative 2, and x is in the set of real numbers. My range is going to be y, where y does not equal, and from before it can't equal 1, nor can it equal 5 over 3, so it cannot equal 1, nor can it equal 5 over 3, but again, y is still in the set of real numbers. Moving on, we look at our next one. I have y equals, and I'm going to factor the top and the bottom, so I need two numbers that multiply out to positive 12, and they add up to negative 7. So that's going to give me x minus 3, x minus 4, all over x squared minus 9, x minus 3, x plus 3. Then from here, we're going to do our sweet cancellation where the negative x minus 3 cancels out. And I get y equals x minus 4 all over x plus 3. Now again, rolling through all of the information that I have present to me right here, my vertical asymptote is going to occur, denominator equaling 0, so it's going to occur at x equals negative 3. My horizontal asymptote, again, I see that the powers match on the top and the bottom, so it's just going to be dividing the lead coefficient, and it'll be at y equals 1. My point of discontinuity occurs when the x equals 3, and then I substitute 3 into this, which will give me y equals 3 minus 4 all over 3 plus 3, or y equals negative 1 all over 6. So occur at 3 comma negative 1 all over 6. My x-intercept occurs when the numerator is going to equal 0, so it'll be at x equals 4. My y-intercept occurs when I equate this to 0. So in this one, what we have is 0. Let's draw it right here. Oh, sorry. My y-intercept occurs when x equals 0. My bad. I just made a little mistake there. Got confused. So we go y equals 0 minus 4 all over 0 plus 3, and y equals negative 4 all over 3. So my y-intercept will occur when y equals negative 4 over 3. From there, my domain, well, I have to look at which values I cannot have with x, and the values that I cannot have with x are when x equals negative 3 and when x equals positive 3. So x does not equal plus or minus 3, and we know that x is in the set of real numbers. My range is going to occur for the values, or I have to exclude the values that y cannot equal. So y cannot equal negative 1 over 6, nor can it equal 1. And again, y is in the set of real numbers. Moving on to the next one. Looking at this equation, now on the top we notice that factoring this is going to be a little bit trickier. So we're going to factor this using the decomposition method, and I'm actually going to take you guys through how to do the decomposition method. I have 2x squared plus 5x minus 3. Now, if I look at this, if we remember from way back when, you had ax squared plus bx plus c. So that would tell me that a equals 2, b equals 5, and c would equal negative 3. So I'm going to go a multiplied by c, which equals negative 6, and b, which equals 5. What I'm looking for here is I'm looking for two numbers that multiply out to negative 6 and add up to positive 5. And then I'm going to use those two numbers to break up my middle term. So two numbers that multiply out to negative 6 and add up to positive 5 would be positive 6 and 1. So right here we're going to go positive 6. Actually, I'm not going to write it in the brackets. I'm just going to write the numbers out. So we're going to go positive 6 and negative 1. I then break up my middle term. So I go 2x squared plus 6x minus x minus 3. From here, I bracket off the first two, and I bracket off the last two terms. I then factor out the greatest common factor for my first two, which would be 2x, whoops, we'll turn that back into black right there in a second, which would be 2x, x plus 3, and then the minus 1, x plus 3. I then factor the x plus 3 out of both of them, and we get x plus 3, 2x minus 1. So what does that tell me? That tells me that my new y is going to be equal to x plus 3, 2x minus 1. And then this is all over x plus 3. Now, moving a bit forward, we notice that we can get that cancellation on the x plus 3, which will give me y equals 2x minus 1. So my vertical asymptote, well, I'm not going to have one because the only thing that we had canceled off. My horizontal asymptote, we notice that the power on top is larger than the power on the bottom, so that means that we're not going to have a horizontal asymptote either. My point of discontinuity is going to occur, well, when x equals negative 3. Whoops. Shouldn't have written that x out there. But it's going to occur when we get the negative 3 in for the x, and then if I put negative 3 into this, 2 times negative 3 is negative 6, minus 1 is negative 7. My x-intercept is going to occur, well, if we look at this function right here, it's pretty obvious where the x-intercept occurs. It happens when x equals 1 over 2. My y-intercept is going to occur, I make x equal to 0, and it's at y equals negative 1. From here, the only points that I'm missing are the point of discontinuity. As such, we're going to have x where x does not equal negative 3, and x is in the set of real numbers, and we're going to have y where y does not equal negative 7, and y is in the set of real numbers. I hope you guys enjoyed going through these examples. We'll get to the next ones in a sec.